Hey everyone, in this video we're going to be talking about electron configurations of ions. If you missed the previous video in which I introduced the concept of electron configurations, I will leave a link in the description below, and I highly recommend you check out that video first. Okay, so let's begin this video by reviewing what ions are, and then we'll talk about how they are different than the ground state electron configurations of atoms that we talked about previously. So, an ion is an atom or a collection of bonded atoms that have either a positive or a negative charge. That means that it either lost an electron or gained an electron. If our atom is positively charged, that means that we have more positive charges than negative charges. And as losing protons is extremely rare and only occurs through either radioactive decay or nuclear fission, therefore, almost all the time working with ions, it means that we have lost an electron. If an atom is negatively charged, the opposite is true, and we now have more electrons around our atom. So, how does gaining or losing an electron affect our electron configuration? Well, if you remember in our previous video, we found that the ground state electron configuration for silicon. Also, remember that we say ground state just means that there are no excited electrons, and our atom is neutral, meaning that it has no charge. But what if our silicon atom stole 2 electrons from another atom? Well, now our silicon anion, which is another way of saying negatively charged ion, doesn't have 14 electrons. It now has 16, leaving it with a charge of -2. So, what do you think that'll do to our electron configuration? Well, all it means is that we now have 2 more electrons to place into our orbital energy diagram here, like so. But what if we were to be left with a positive 2 cation instead? Cation just means positively charged ion. Well, now we need to decide which electrons we are going to get rid of. And as you may have expected, it makes sense to get rid of the highest energy electrons, as they're the ones held least tightly by our atom's positively charged nucleus. So we just removed the last 2 electrons and we are left with the following electron configuration of our silicon cation. If you're at all still confused on the electron configurations of either neutral atoms or ions, check out our next video in this series, and we will complete tons of examples finding the electron configurations of various atoms and ions. Thank you for checking out this video, and I hope it helped your understanding of what the ion electron configurations are. If you enjoyed, please like, subscribe, and consider checking out our YouTube memberships down below by clicking the join button, or our Patreon page. However, if you have any comments, questions, or concerns about the information I provided in this video, please leave a comment down below and I will do my best to address your concerns.